Hi guys, and welcome to Trigonometry Grade 11. I'm Mr. G. I thought maybe I should reintroduce myself once again. There's just been a few suggestions that maybe once in a while I should put up a video where I appear, and this will be one of those cases. I just want to chat a little bit about trigonometry and geometry. These two topics of maths, guys, are inseparable. You cannot study them independently. In other words, you must understand geometry in order for you to make sense out of the trigonometry. As a matter of fact, I was just thinking to myself, the word trigonometry itself, if you think TRI, that is basically triangles. So geometry, triangles are geometric figures. So actually in trigonometry, you are studying triangles. We established in grade 10. If you like, you may have a look at that video where I introduced trigonometry. I emphasized that trigonometry actually comes from similar triangles. So trigonometry coming from similar triangles means that we cannot really understand fully what goes on in the trig unless we have a good understanding really of what we learned in the geometry. So they are interwoven in some way. So it is really important that you now and then try and link what you studied in geometry with what you are studying in trigonometry. Now, I'm introducing here reduction formulae. The 90 reduction, the 180 reduction, the 270 reduction is not really part of the CAPS requirement, so I will not really talk about it, but the idea is the same, the 360 reduction. Now, what is happening here with these reductions? What's going on? Why should we even reduce, or what motivated this? I will be answering these questions before now we start looking into problems that include reduction, okay? In the previous video on trig introduction for grade 11, I had already spoken about the 90 minus theta reduction. And you have seen right from the first quadrant, that triangle that I set up there, that the angle 90 minus theta was included therein. And so we just had to reposition ourselves to and use 90 minus theta as our angle of reference, and then use the normal definitions for the trig ratio. Sine of theta was opposite of a hypotenuse, and we saw that the answer that we got was actually x over r, and that was cosine of theta. So we are done with the 90 minus theta reduction. We are going to look into the 90 plus theta reduction. And as a way to kickstart this conversation, 90 plus theta, if you think about it, we are basically doing some geometry here. And now this is where I prove the point again. We are doing some geometry because 90 plus theta means you are actually rotating the point that you have, okay? Your angle is at a certain point theta, okay? Your point, okay? Now what you're doing is you are rotating that point 90 degrees above the origin. Allow me to just stop the video here and go into the nitty-gritties of this whole thing. So I will share my screen right away and show you what I mean by that, so that as I talk, you can actually relate to this. Maybe as a matter of fact, let me just start with what motivates us to actually do these reductions, okay? To start with, if you look at the graph that I have here, you will notice a few things. This is the sine graph, by the way. So you notice that at this point, okay, in other words, sine 90, I get 1, okay? And this is the same as somehow sine 450. Maybe I went a little bit out. But also notice that I get the same value of 1 when I'm at negative 270. Let me bring it a little bit home. We notice somewhere here, let me just sit here, okay? Notice that at this point that I'm marking blue, there is a specific angle there. Unfortunately, I've just used 90 degrees as my step, so we will not be able to see exactly what that angle is, but I'll switch to a nice animation where we can see the exact angle. We see that this angle is the same as this angle here, okay? And they have a value here, okay? And that value is actually what? Half, okay? Because if you think about, if you look at our scale of the y-axis here, this is just halfway to 1. So we see that at half, 1/2, okay? There are two values, okay, for x. So there are two x values that meet this requirement. Here's the first x value, here's the second x value. Now, well, I know what these values are, but I want you to investigate with me what these values are, okay? So come with me now to the trig top, and we're going to figure out what those values are. Let me switch to the sine graph. There I am. Now, I'm currently here. We're gonna move first, okay? And we want a value of half, 1/2, okay? Let's see if we can get that. 0.522. Please pay attention to the y value here. That is the value that we are looking for. We want exactly 1/2, okay? There it is, 1/2 is 0.5. So you notice something. We have here exactly 0.5, all right? You can see it's y/1. So that means that value that I was talking about in the other animation is this one here, half. So the x, the angle that we want here is actually what? 30 degrees. Okay, but I said, look, as I said earlier on, there must be another value somewhere here. Okay, my line went quite wrong here. There must be some other value here that also should give us 0.5 or 1/2. So let's go through this unit circle and see which value is that. You will see as I'm going through. In fact, let me go through the sine graph. We want a value somewhere here that should give us 0.5, exactly 0.5. So let's see. Okay, I'm gonna try and be accurate a little bit here by doing that. And there we are. The angle here is actually 150. So we see that, okay, x at 30 degrees is the same as x at 150 degrees. In other words, the ratio of sine 30 is the same as the ratio of sine 150. That's what the graph is telling us. And in the same sense, the graph is also telling us actually that at some point here, okay, a ratio of a certain angle will be exactly the same as the ratio of another angle there. Let's try and investigate this and see what is happening. Let's see. Let's come down there, somewhere there. Okay. Let's see what that ratio is. This ratio here, sorry, I went a bit further. This ratio here, maybe let's say, let me make this angle 210. Okay, oh, I want to try and make it 210. Yes. Okay, somewhere there, roughly there. The ratio is minus 0.5, it's minus a half actually. Which ratio again will give us minus a half? Roughly there, let's see, we're getting somewhere. Oh, we went a little bit. Oh, somewhere around 330. So again, the ratio of what? The ratio sine 330 will give us a minus half. So again, we establish something here. The graph tells us a story. For one ratio, we will always have two x values, okay? Now, if we don't pay much attention to the sign, because I mean, this is minus a half, that's plus a half, half is the same value. So if we choose to ignore the negative sign, we see that actually there are four values, okay? Four x values that are different, and they all give us the ratio half, 1/2. So this is actually what motivates the reduction formula. Actually, what you will see down here, the reason we have a minus a half here is because sine is negative at this point. Sine is also negative at this point, but we essentially have the same ratio. Here we don't have a minus a half, we have a plus a half because sign is positive up there. In essence, sign is positive in the first and the second quadrant. Now, guys, I could go on do the same thing for the cosine graph, but of course that will just be redundant. I want to just think of the same way for the cosine graph. There it is. The strategy is the same. By now in grade 11, you know how to draw these graphs, and actually you are now going to start shifting them left, right, up, down, stuff like that, playing around with the amplitude. So this is just for motivational purposes as to why should we bother about reduction formulae. Okay, so I hope you have caught that. I am going to stop here for this part. And then in the next part, I am now going to move on and show you then how do we determine sine 90 plus theta? How do we determine sine 180 minus theta or 180 plus theta, etc. and etc. And you will see this, I will be now using purely the Cartesian plane, but if you like, you can have a trick graph somewhere close by. And for you to do that, guys, just go on your phone, cell phone app. If you're using Android, then just go to Play Store there and search for Desmos graphing calculator. If you are using Apple, go to your Apple Store, App Store there and search, of course, Desmos calculator. You'll get this nice app, and then it will help you with the graphs, the functions that we do, from algebraic functions to trig functions. You'll be able to graph them nicely and play around with the parameters and see what you're doing. That's exactly what I'm using here. Of course, I'm using the web version, as you can see. So go ahead and download that app so that when I address the reduction formula on the Cartesian plane, you can also play around on your graph and see actually what is happening between 90 and 180, what is happening between 0 and 90, etc. So that being said, I'll catch you guys later.